The sun. Brilliant, powerful, giver of life. But this is the story of how the sun will one day become our enemy. If we are to survive, we'll have to leave the Earth. We'll need to seek out new homes in amazing new places. And change other worlds to recreate the Earth we left behind. In the far future, our sun will become a monster. It will burn all life from our planet, destroy entire worlds. And finally, our sun will even destroy itself.
It's going to happen. One day our sun will die, and when it does, we'll go with it. It's time to think about the future.
For 5 billion years, the sun has nourished the Earth. It is the sun that provides the energy for plants to grow. It is the sun that makes life on Earth possible. But that will change. Slowly, unstoppably, our sun is getting hotter and hotter. Once it gave life to us all, but what it gave, it can also take away.
If human beings are to have a long-term future, we must leave our planet behind and search for new places to live. One day, our homes will be out there, somewhere in space.
In the distant future, this could be our home. Out here in space, we'll have to seek refuge on new worlds where we could settle and live. The reason is, we have to escape from our sun. Some new worlds may be difficult to adapt to. Others may be very like our own. But what is it that makes our planet so special? And why is it so dependent on the sun?
Here is the sun as it is today. In the center of our solar system. The Earth goes round it about there. There are the other planets. The reason why our planet is the one with life on it is that it is just the right distance from the sun.
Closer in, and we'd boil. Further out, and we'd freeze. We live in a kind of safe zone that's perfect for life.
The trouble is that zone is moving. The sun is getting hotter, and as it does, the region where life can exist shifts further and further out. Ultimately, the safe zone will leave Earth behind. When it does, we'll be in serious trouble. Our planet will die.
This is how it will happen. As the sun burns up its nuclear energy, it will become hotter and hotter. By the time it's 5% hotter, plant life everywhere will be dying. %10 hotter, and animals too will begin to die. 15% hotter, rivers and oceans will evaporate, creating huge cloud banks, trapping more and more heat. In the far future, life on Earth will become impossible. And there's nothing we can do about it. What will happen to us then? Astronautical engineer Robert Zubrin believes he has the answer. He wants to find us a new place to live.
The only real choice that we have is to grow, expand, become a spacefaring civilization, or to become extinct. Not only would we become extinct, but unless we become a spacefaring civilization and bring Earth life out with us into the universe, all life on Earth will become extinct.
Robert Zubrin's goal is to make us a home on Mars. Today, Mars is cold and lifeless. Temperatures regularly drop to 100 below freezing, and its atmosphere is 200 times thinner than our own. A person standing unprotected on the surface of Mars would be dead in seconds. Yet some scientists believe we could still learn to call this home.
Mars is the only other planet in our solar system that has on it all the resources needed to support life. It has water. It's frozen to the surface as ice and permafrost, but it's there. It's got carbon dioxide in the atmosphere. It's got nitrogen in the atmosphere. And if humans go to Mars and develop the craft of how to use these resources, then we can make Mars a place where human beings can sustain themselves. We can make a new world for our posterity. No species can expect to last long if it stays in the same place. In a very real sense, humans are not native to the Earth. We're not native to North America. We're not even native to Europe. We're native to Kenya. That's why we're tropical animals with long, thin arms, no fur. But humans were able to leave there and colonize the Earth by becoming creative. Man the inventor. That's how we coped with Ice Age Europe, and that's how we're going to cope with Mars and the planets beyond.
In a remote part of Canada, researchers have already been preparing for life as pioneers on Mars. Living in a space pod did prove difficult, but they coped. Zubrin is optimistic.
We're ready to take this on. And frankly, if we shrink from this challenge, what it would really mean is that we have become much less than the kind of people we once were.
Ignition sequence start.
We are much better prepared today to send humans to Mars than we were to send people to the moon in 1961 when John F. Kennedy started the Apollo program.
I believe that this nation should commit itself to achieving the goal of landing a man on the moon and returning him safely to the Earth.
And we were there 8 years later.
The Eagle has landed.
There is nothing in this that is beyond our technology. It's just a question of showing a little bit of moxie.
For Zubrin, it's not the technology that's lacking, it's the will. But technology and willpower alone may not be enough. Just look at what we'd leave behind. This is our life support system. The plants that create oxygen, countless species of animal, how will we fare without them?
Our survival depends on the living things we share our planet with. The air we breathe, the food we eat, all this is created by other forms of life. If Mars is to be our home, it'll have to be home to all of this as well.
15 years ago, we thought we knew the answer. This is Biosphere 2, a huge glass dome covering 3 acres of Arizona desert, completely sealed off from the rest of the planet. The theory was that people could survive in it because the whole environment was self-sustaining. Trees would provide oxygen, artificial clouds and oceans would regulate the climate. But the experiment failed. Food rapidly ran short, extra air had to be pumped in. On Mars, that failure would have killed them all. If we're ever going to call the Red Planet our home, clearly something's going to have to change. And the easiest thing to change may be Mars itself. It's an idea called terraforming. The aim is to transform a whole planet from a place where we couldn't survive to one where we could. NASA scientist Chris McKay believes we could turn Mars into something surprisingly like Earth.
When we think about going into space, we tend to focus on humans. But in fact, it turns out that it's easier for plants and microorganisms to go to Mars first. They're going to be the first Martians.
In Death Valley in California, Chris McKay is seeking Earth's most hardy creatures. Creatures that might be able to survive on Mars.
That's our guys.
These green smears are algae, microscopic organisms that can thrive even in the harsh and variable climate of Death Valley.
You can see that.
And they could thrive on Mars too. Sucking in its thin and unbreathable atmosphere of carbon dioxide and pumping out oxygen in its place. Except at the moment, even the algae would find Mars deadly.
The first step to make Mars habitable even for the toughest little algae, is to warm it up a bit. Right now it's too cold and too dry for any type of life from Earth. Well, warming up a planet is something we know how to do. We're doing it on Earth. The pollution on Earth would be the medicine on Mars.
It's a strange twist. The best way to make Mars a place we could live may be to pollute it. Here's how it would work. First, a spacecraft has to drop off the pollution-creating machines. Job is to suck up a mixture of Martian dust and atmosphere and process it into new chemicals. It then belches out these greenhouse gases to warm the planet, and dark soot to soak up heat from the sun. If we send enough machines, over time, Mars will warm up enough to allow these algae to survive. And the algae will begin to give Mars an atmosphere of oxygen. But to speed the process up, we would need more efficient oxygen makers. And the best that we know are plants and trees.
The real goal to making Mars breathable is to get trees growing there. Those trees, those will be the ones that make the habitable world. And then things will really start happening. As the oxygen level built up, insects, maybe small animals, and eventually large animals, and maybe even humans, could then survive naturally.
We could change Mars.
If I were to lay out a time scale, I would say 50 years humans go to Mars, and soon thereafter the algae and the bacteria go to Mars. And then maybe 30 years later the trees go to Mars. And then the humans come back, but this time in a natural setting that's biologically suitable for them. And then we've learned how to become a life form that lives on 2 planets, not just humans, but all of life.
It's a bold and astonishing plan. If it works, we could turn Mars into a planet very much like Earth. But even Mars will not last forever. Even there, we could never escape the power of the sun.
As the sun keeps getting hotter, the safe zone for life moves further and further out. This is Mars. Now Earth's dead, this is our home.
Thanks to our terraforming, it looks a lot like Earth. And thanks to the hotter sun, it's now in the safe zone. The only trouble is, the sun is still getting hotter. Eventually, the safe zone will leave Mars behind as well. And with Mars dead, David Brin is a science fiction writer. He imagines future worlds for a living.
Well, it's a big universe out there, and the Earth is a very specialized environment. But we're not going to find many Earths out there. If we want to spread out into the galaxy, then we're going to have to adapt to the universe. It's not very easy for human beings to get accustomed to that idea because we're used to making the environment adapt to us.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off!
As the sun becomes hotter, new worlds will warm into life. This is Europa, one of Jupiter's huge moons. We know it today as a frozen planet, airless, with a crust of iron-hard ice. But in the future, it will be something else entirely. The ice will have melted. Europa will have become an ocean world. After Mars, perhaps we'll come here and make this our new home. We could live in cities at the bottom of an alien sea. But David Brin thinks that in the end, a life behind glass may not be the solution.
Now we're thinking of going to other planets. At first we'll arrive in spacesuits, live in domes, bringing our earthly environment with us. But eventually, people will want to get out of those domes, and part of that will involve changing ourselves to fit into new environments.
Our ancestors evolved for life on Earth, but Brin thinks our descendants may redesign themselves for a future on other worlds.
Human beings have been wonderfully inventive in the last 20 million years, and yet other species have not been idle. Birds develop lungs which the air flows through from one side to the other, so all of the lungs are used. We only use about half of our lung capacity. If we were to just genetically engineer ourselves so that our lungs flowed through like those of birds, think of the thin atmospheres that we could live in. Wouldn't it be great to be able to hibernate like a bear? We'd be able to travel to far planets, possibly even far stars. And if they live and work in zero gravity, eventually they're going to get sick and tired of pulling around a third of their weight in these useless legs, which are only good occasionally for pushing it against walls. Why have legs if you're in zero gravity, when you could have 2 additional arms? Wouldn't it be more functional, jumping all over the place like gibbons? Can genetic engineering achieve any of these things? Who knows? We're just at the beginning of this grand adventure. But it's an extravagant version of tomorrow that we should be thinking about. Wouldn't it be a desirable thing? If they're happy, if they're creative, if they're productive, if they're part of a great civilization. Vive la différence.
We can only guess at the future. What will our descendants be like? We'll have to wait and see. And where will they live? Because the only certainty is it cannot possibly be here. It's not just that the sun will have seared all life from planet Earth. It's that the planet itself will no longer exist. Everything we know will have disappeared. Because in the far future, our sun will turn into a monster. It's going to consume the solar system. Its first victim is the closest planet, Mercury. Next, Venus is transformed into a molten fireball. And ultimately, boiled away. And still the sun grows. It's 160 times its original size, 2,000 times hotter. And its next victim is the Earth. Long since seared barren by the sun, the place we once called home now melts and is engulfed. 7 billion years from now, the Earth will be gone. For us today, one question remains. Is the future of our planet also our future? Can we really survive the death of planet Earth?
Look at where we stand today. Look at how far we've come. Compared to the world of 100 years ago, we're living in a science fiction universe with skyscrapers 100 stories tall. Who can believe, looking at that looking forward to the next 100 years, there will not be a new branch of human civilization on Mars? And look back 1,000 years now. The world lit only by fire. Who can say that 1,000 years from now, there will not be hundreds of new branches of human civilization filling out worlds orbiting hundreds of stars in this neck of the galaxy? Some people think that we're living at the end of history, but I couldn't disagree more. I think we're living at the beginning of time, where present are the creation, It's a glorious time to live.
For all we know, we might be the only life form in the galaxy and the universe. If that's true, I think that really deepens the importance of the role of humans in spreading life beyond the Earth. If we're the only spark of life, then we certainly don't want that spark to go out.
Our scientists today are already imagining strange and far-off tomorrows for our kind. And if we do survive, perhaps we will be there to witness the moment when our sun's transformations finally end. It was first the giver of life, then the destroyer of worlds. And now, it too is doomed.
This is the sun at the end of its life. Layer after layer, it is blowing itself apart. Huge clouds of star stuff drift out into space. It's a slow process, it takes millions of years, and what follows is inevitable: the death of our sun.
It casts off one final layer, and its spark is extinguished forever.
So the sun will one day go out. Will that be a significant event to our descendants billions of years hence? I don't think so. They will have observed a similar phenomenon on innumerable other stars long before that time. But if they did think about it, they would note with gratitude that their ancestors did not stay on that one little world and await their doom, but rather spread forth into the universe and made their life possible.
No one can know our future, but our sun's future is certain. There will come a time when we must leave our Earth behind. Our planet will be gone. We humans have come a long way, traveling our world in search of new lands, spreading to every corner of the globe. But the time has come to look to new destinations, to go once more into the unknown. This is the story of our journey in space. We will fly to the stars on a ship that sails on sunlight. We'll explore the most distant edges of the cosmos by taking a roller coaster ride through the very fabric of our universe. And we'll discover the machine that has charted the heavens as never before. It's the voyage of a lifetime, a voyage to our future in space.
We've always had the urge to explore. Our ancestors journeyed into the unknown to discover new lands, and now it's time to do it again. But this time, it's not a voyage between continents. This time, it's a voyage to the stars.
As our telescopes get ever more powerful, they have shown us a universe of unimaginable beauty and power. Vast clouds where new stars are born. Strange galaxies. Even tantalizing hints of new worlds. But they've also shown dangers. Disasters so huge they could destroy the Earth in seconds. Space is full of terrors and wonders. But will we ever see them for ourselves?
We have a dog.
It's less than 50 years since we took our first steps out into space. Since then, thousands of rockets carrying hundreds of people have made the 10-minute flight into orbit. Astronaut Story Musgrave is one of a new breed of space adventurers.
When you see a launch from the outside, it's a rather glorious, magnificent thing. Inside, it's the absolute opposite of that. It's 137 decibels. It's shaking. Everything is shaking. You have the solid rocket boosters that are really pounding the vehicle and all. And then you have the turbulence in the atmosphere that adds another shake, rattle, and roll. And so you're basically in a small closet here with belts and straps and helmets and gloves and parachutes, survival gear, and you got all of this. It is all over you, and at the same time you're being shook. And it can't help but pass through your mind, you just want the whole stack to hold together. You're along for the ride and you want to survive that. So it's not a joyride for me. It's what I need to go through to get into the incredible serenity and the celestial dance of zero gravity.
Hello, Houston. We are inspired. We are ready. Let's go fix this thing.
We are becoming a race of spacefarers. It's a strange and unfamiliar world. But for the privileged few who go there, it is an experience they can never forget.
Spacewalking is much more like a dance than anything else. You choreograph every move. You choreograph every finger, every toe, every body position, and how you're going to do all of that. It's just as precise as a ballet. Going into space, it's opening night at the ballet. During a spacewalk, I love to look at my feet. You see your boots going 18,000 miles an hour, 25,000 feet per second. You see your boots going down the road. If you ever want to play Superman, that's where to do it.
We stand on the edge of space. Our most ambitious project is testament to what we have achieved. The International Space Station, Freedom. But it's surprisingly close to home. It's floating less than 400 kilometers above our heads. The furthest we've traveled into space is this. In 1969, we set foot on the moon.
That's one small step for man, one giant leap for mankind.
For the first time ever, we looked back at our home from the surface of another world.
It's amazing to think that people have actually walked up there.
Voyager left Earth in 1976. It passed Jupiter, then Saturn, and now it has left all the planets far behind. After decades in space, it's 14 billion kilometers from Earth.
It's an impressive journey, until you consider this. On this scale, the nearest star to our solar system is way over there. In fact, it's over 100 kilometers away. To reach it would take Voyager another 25,000 years.
At Voyager's speed, even reaching the nearest star is an impossible journey. But perhaps there's hope. It's easy to forget that in a single person's lifetime we've gone from this to this. And in our quest to reach the stars, some scientists believe the answer could be to go from this to this, Deep Space One. Its secret is a new kind of engine, the ion drive, and it's the passion of NASA scientist Mark Raymond.
The idea for ion propulsion's been around since long before I was born, but the first time I ever heard of it was in a Star Trek episode. They're using ion propulsion, and Spock says, configuration unidentified, ion propulsion, high velocity, unique technology. And I thought, well, this is really amazing, but I'm never going to see anything like that in my lifetime.
But in 1998, Mark Raymond's dream became reality. Deep Space One. But what is it that makes the ion drive so different? Compare it with a conventional rocket. The rocket fuel burns with tremendous force, and as it thrusts down, it pushes the rocket up. In the laboratory, Mark Raymond watches a prototype ion drive in action. Instead of tons of rocket fuel, the engine uses a few grams of a gas. It gives the gas an electric charge and spits it out atom by atom at incredible speeds, creating a seemingly gentle blue haze. The ion drive doesn't have the raw power of a rocket. It has something better, staying power. It's a bit like the hare and the tortoise. Conventional rocket engines create huge thrust and awesome acceleration. But they burn through their entire fuel supply in just a few minutes. After that, it's all over. The ion drive is nowhere near as powerful. In fact, it would take Deep Space One 4 days to get from 0 to 60. But the reason Deep Space One is the fastest spacecraft ever is because it's been accelerating for almost 2 years.
When we communicate with that spacecraft out so far in the solar system, to think that our baby is out there, this little spacecraft that we built, I think it's really amazing.
Iron Drive spacecraft will be fast enough to chase down comets or travel around the planets of our solar system in just a few months. But even iron drives don't last forever. Eventually they too will run out of fuel. To travel further, to reach the stars, we'll need something new. And it may be based on one of the oldest technologies we know, the sail. Long ago, the limitless power of the wind carried our ancestors to new worlds. In the future, we may use the same idea to travel to the stars. On sails that catch nothing more than sunlight. A solar sail, using only the light from our sun. Many scientists are sure that this is the future of space travel. One of them is Les Johnson.
The sun puts out photons, light. Standing here on a sailboat, the photons that are falling on us are pushing on us. But the push is so slight that we don't feel it. All the other forces around us are so much higher in magnitude that it's not noticeable. But in the vacuum of space, if you have a large enough, light enough material, the pressure that's exerted from these solar photons can cause that to move.
To see if sunlight could provide enough force to drive a sail through space, Johnson and his team built this, a man-made sun.
In front of me, we have a simulated sun, about 3 times brighter than what the sun is at the Earth. And that's the reason I'm wearing these UV protecting sunglasses, and that it could damage your eyes if I were to accidentally look right into the beam.
They're testing the ultra-thin, ultra-lightweight material they would need to make a real solar sail. It's mounted on a rod in the full glare of their artificial sun.
As you look in there, you can see it slowly rocking back and forth. What's causing that is a sunlight pressure, the photon pressure, as it's pushing on the sail.
Incredibly, it works. This piece of sail material is being moved by nothing more than light.
Based on work that's being performed around the country, solar sail technology is getting to the point where very soon we'll be flying it in space.
To reach the immense speeds needed to travel from star to star, the solar sail must start its voyage with as big a push as possible. It must fly as close as it can to the source of its power, the sun. It's a dangerous maneuver, but if it works, the craft will whip around the sun and hurtle out into space at almost 3/4 of a million kilometers an hour. A solar sail could reach the nearest stars in just decades. It's a truly impressive start, but is it enough?
Our galaxy is a very big place. To get from one side to the other, even using a super-fast solar sail traveling at incredible speeds, would still take 2.5 million years. And our galaxy is only one of billions that make up our universe. And this is the final frontier. If we ever want to be true star travelers, we're going to have to take a completely different approach. We're going to have to learn how to manipulate the very fabric of space itself.
Some scientists believe there may be a quicker way to get around the universe. One of them is cosmologist Peter Coles.
When early man first began to explore his environment, he would run into fundamental barriers whenever he came across mountains. The mountains are not easy to cross. When you're faced with a wall like these mountains around us, you've got no choice either but to go around them or over the top. Now these days it's exactly the same thing with space travel. If we're going to explore and colonize our galaxy, then the distances we have to travel are truly immense. So when it comes to space travel, we're really still very much in the Stone Age.
The answer could be to take a shortcut. Don't go round the obstacle, go through it.
If you travel through space, you're fundamentally limited by the speed of light. But it's just possible that the laws of physics might have a kind of loophole in them which allows us to travel slower than the speed of light, but still travel huge distances in a very short time. And the way you can accomplish that is through a wormhole. A wormhole is basically a tunnel that takes a shortcut through space-time. Say here to the nearest star could be connected by a very short tunnel.
Wormholes may sound like science fiction, but creating one may just be possible. First, we'd have to harness the incredible forces of an exploding star and use them to punch a hole through space. We'd need exotic forms of energy to keep the tunnel open. But the science is sound. At least in theory, it is possible to create a tunnel that reaches clear across the universe. Experiments have already begun to try and build the first tiny wormholes.
In theory, wormholes would take you from one side of the universe to the other in literally no time at all. Instant travel anywhere. A wormhole could just as easily have taken me halfway across our galaxy. But with the universe at your feet, how do you decide where to go? For that, you're going to need a map.
Space, as we've discovered, is very big. But Professor Brian Boyle and a team of Australian astronomers may have the beginnings of an answer. They're creating the biggest map imaginable, a map of our universe.
Traditionally, astronomers had looked at the universe as a flat map on the plane of the night sky. You can think of it like a map of the Earth. For a hiker, a flat map, it's no use at all. A flat map wouldn't tell you if there was a mountain in the way or a huge ravine. In the same way, the hikers of the future will need a three-dimensional map to guide them around.
To create a three-dimensional map, Boyle and his team had to develop a unique piece of equipment. 10 years in the making and weighing over 3 tons, the device uses over 600 fiber optic cameras. The whole apparatus is delicately maneuvered into position high up on one of the biggest telescopes in the world.
Everything's connected up, we're ready to go. Fibers in position. What we're going to do now is to take the telescope back up to the top and wait for the stars to come out.
Every night, the telescope looks at a new patch of the night sky. And for each point of light it sees, a robot places a single fiber optic camera. The light from the object is measured and its distance from the Earth accurately calculated. So far, the tireless robot has looked at and logged the positions of tens of thousands of stars and galaxies. Bit by bit, it has pieced together an unequaled picture of the universe. And this is the result. For the first time ever, we can see what our universe looks like in 3 dimensions.
When the map was first created, I was really filled with a sense of mixture of awe and excitement. Here I could see, almost developing in front of my own eyes, was the structure of the universe. Giant archipelagos of galaxies stretching hundreds of millions of light years across intergalactic space.
The day before I'm going to launch from out here, I go to the beach, right over there. I go to the ocean. I lie in the ocean and I look at the satellites crossing overhead, but I look at those satellites just whizzing along, and I think, tomorrow that's me. So I think on that kind of thing where you don't know if you're coming back and you don't know the final outcome and you may not really know where you're going to end up, you focus on a journey and that's what carries you forward.
There's a lot out there to explore, and one day humanity may be lucky enough to do it. Our children or our children's children will reach for the stars. So the next time you look at the night sky, remember that space is stranger and more beautiful than we can begin to imagine.
And above all, remember this. Out there in space is our future.